everyone. So today we're going to start looking at systems of linear inequalities. So far we've only ever graphed one inequality at a time. Today we're going to be graphing two or more inequalities on the same graph. And we also are going to identify the solution set of this system, and that's going to be the area that is shaded by both inequalities. So the double shaded region. So to start out with, our first example, both of my inequalities are in slope-intercept form. So y equals mx plus b. So this is going to make it a lot easier to graph them. So for the first one, let's put a purple dot next to it. That way we know we're graphing in purple. It has -1 at the end, so I know it's going to cross the y-axis at -1. So I'm going to put a dot there. And then the slope of this, I know there's no number in front of the x, but we know that when there isn't a number, that's an invisible 1. So our slope is -1. So when we count slope, we're going to go down 1 over 1, down 1 over 1, down 1 over 1, and so on. So just put some dots so I can match them up. Okay, and then lastly, the symbol here is a greater than symbol. So greater than means that we are going to have a dashed line and we are going to shade above. Okay, so I'm going to try my best to graph this line for you guys. Okay, so there's my line. And then we said that it needs to be shaded above. So everything up here gets colored in. Okay, now let's look at the other inequality that is there. This one we're going to do in pink. So this one is y is less than x minus 5. So -5 is its y-intercept. So I'm going to put a dot there. And again, this time, there is no number in front of that x. So that means that there's an invisible 1 there, and our slope is 1. So we're going to count starting from our y-intercept, up 1 over 1, up 1 over 1, up 1 over 1. Let's just put a few dots so that I can use them as a template. Okay. Now let's take a look at the symbol. It's a less than symbol, so that means that, again, this is going to be a dashed line, only this time we're going to shade below. So let me draw the line and then we'll do our shading. So dashed line. And shade below. So that would be down here. Okay, and that's the system of inequalities. It's basically just two inequalities on the same graph. So I didn't put this on the notes, but I think we should answer it. Are the following points solutions? So solutions, question mark. So what if I had the point, let's call this point x, the point 2, 2. So I'm going to go to my graph. Here's point 2, 2. So it's in the purple part, yes. But in order to be a solution to the system, it has to be in the double shaded area. And this is only shaded purple, so this one would be no. What about the point, so point y, let's say the point 5, comma, -2. So that would be right here, point y. And yes, look at this. So it's in the purple part, but it's also in the pink part. So since it's in the double shaded, yes, this counts as a solution. Okay, now let's look at our second example. I have the system, x plus y is greater than or equal to 4, and x minus 2y is less than -2. So this time they're both in standard form. So we're going to have to rearrange them a little bit before we can graph them on our graph here. So let's start with the first one. I'm going to make that one be our green one. X plus y is greater than or equal to 4. I want y to be by itself. So the first thing I'm going to do is subtract x from both sides. That way it can cancel. And I'm left with y is greater than negative x plus 4. So good job, we have y all by itself. That means it's going to have a y-intercept of 4, a slope of negative 1. And before we even start graphing, this would probably be a good idea. Greater than or equal to has that underline, right? So this is going to be a solid line, and it's going to be shaded above. Okay, now let's look at the other equation. X minus 2y is less than negative 2. I want y to be by itself, so first let's start by subtracting the x. And that leaves me with negative 2y is less than negative x minus 2. But y is still not by itself. It has that negative 2 in front. So let's divide everything by negative 2. And I get y. Now this is one of those special cases. I divided by a negative number. So that symbol is going to flip to greater than positive 1/2 x. Because remember that there's an invisible 1 here. Negative divided by negative makes it positive. And then negative 2 divided by negative 2 gives us positive 1. And taking a look at that symbol, greater than, this is going to be a dashed line, again shaded above. So now let's go ahead and graph these two inequalities. So let's start with this one right here. Y is greater than negative x plus 4. So I'm going to put plus 4. And negative x means down 1 over 1. So it's going to kind of go like this. And we said for this one, it's a solid line colored above. So let me do our solid line. And shaded above. Okay, now let's do the orange one. That one is y is greater than 1/2 x plus 1. It's going to have a y-intercept at positive 1. Its slope is 1/2. So that means starting from that y-intercept, up 1 over 2, up 1 over 2, up 1 over 2. But we're going to use a dashed line when we do that. So that's going to be something like that. And for this one, we also want to shade above. So everything above that orange dashed line is going to get colored in. So our solution set is the part that's colored both green and orange, the part that got double colored in. So this area right here is my solution set. So let's test out a few points. Solutions, question mark. So if I had the point 2, negative 2, and let's call that point x. So 2, negative 2 is down here. It's in the white part, so this one is an obvious no. So now let's do point y, and let's make that be negative 3, comma 2. So negative 3, 2 is right here. So it's in the colored in part, but it's only colored in orange, and I need it to be colored both colors. So that one doesn't work either. So let's try one that's going to work. So point z, let's say that it's at positive 3, positive 4. So 3, 4 is right here. So see how that part is colored both green and orange? So yes, that one does count as part of the solution. Okay, and like always, you could always go to desmos.com to graph these. That way you can double check that you're getting the correct graph. So desmos.com. But other than that, that's what I have for you guys today, and I will see you tomorrow.